Hi everybody, my name is Siniak. I'm from Belarus, and I would like to give a short talk about the reverse engineer of a kind of 3D computer game. It's called Toribash, and it's a martial arts simulator, and it's been developed in 2008, and for now it's like maybe 30 users online, so it's not that much popular. But anyway, this game has a very nice physics engine, maybe not that much precise in terms of the physics, the real one, but it can be used for some kind of other task. In my case, it's machine learning, but I'm not going to talk about it now. So the point was that the game had the built-in Lua interpreter that you usually have in the game. Like you can type some commands, like say in the Counter-Strike. So the developers, they did really decent job. I mean, they put almost all of the SDK into the Lua commands. Although they didn't provide the source code, you can still like modify the game. So it's been used really greatly by the community around the game. But the point is that the game didn't have the bot, the proper like the opponent. So like I was thinking, okay, let's try to provide the proper bindings for the engine. The limitations is that the developers, they linked Lua interpreter statically. I know that currently you can fetch the source code and compile the shell library, at least in r2con it's so, but the thing is that either it was the obfuscation step or just because that time Makefile didn't have the option. So you're not likely to do like simple tracing and trying to understand the workflow of the game and to be able to get in between the game and the Lua interpreter, for example. And the other thing is that they limited the virtual machine of Lua. You are not able to insert the module you would like. You're likely to compile yourself with C++, for example, and load it as the dynamic extension. So like you will have all the SDK in Lua, maybe simple intermediate code, and the rest will be done in some like normal software development case, like in C++ module. In my case, I needed bindings for the Python because it's really difficult to switch to another technology if you have like a simple stack like C++ or Python. So the goal was to reverse engineer the game engine and to obtain the Python bindings as easy as you can, because of like reverse engineering the 6 megabytes binaries can be difficult. So at the end, what has been done, just being fancy, the game is available in Steam, so it all the time asks you to provide the credentials. So the thing was like, can we stop the Steam library, for example, because that one was shared one. So yeah, it's possible. You just create some simple library with the same names for the functions, following the C convention for naming, and inject that library, and the linker will resolve the methods and will feel okay. I mean, in Steam has like 20 symbols you have to implement, and that's fine. And after that, you should try to mimic the behavior of the library. Actually, that's where I've been looking at the behavior of the game in Radare and trying to stop it as quickly as I can. So most of the time it was like the game expects to obtain some the interface class from Steam, and it's gonna call some method. So usually it was like constructing from scratch the pointer to some memory where you generate the virtual table from scratch, put there like a single method at a particular offset, and that method can return, for example, the username for the player, the not real one, but just any you can, and so on. The first step, the game is really huge. When I just like open up the binary and was looking through it in Radare, just to understand what's inside. It was easy to spot places where the Lua interpreter is initiated, just to search for the strings you usually encounter during the usage of the SDK for the game. Second thing, there was really lots of stuff related to the graphics, because the craziest idea is try to obtain the ideal solution when you have bindings for the engine itself and throw away all the stuff around the game. But it's difficult, and later on I discovered that this, the Mujoko environment, it's very popular for reinforcement learning, but it's a bit different and it's unique, it's genuine, and it's like too old, and it's funny to play with this one. So in the end, I just discovered the place where the some Lua call is implemented inside the game, and it was easily to spot the 8-byte or 4 bytes pointer to the Lua context. And the idea was like, okay, let's try to forward this context to some C++ library you're going to inject, and link to that library a normal shared version of Lua, and use the context and the Lua library to communicate with the game if it's needed, because the API is rather rich, but it's not gonna to extend it in the way of Lua. And so just find the pointer, patch a couple of lines that would, instead of calling the game logic, you would pass just the pointer, just call some C++ function from the library and pass there the Lua pointer. That's usually enough, because from the context of Lua you can fetch all the command line arguments from the Toribash console. So the second step was to write the OpenAI gym-like environment, where you have just a simple import statement in Python. You can reset the environment, obtain the current state of the game, make the step, and be able to detect when the game is over. You need to restart a new episode. So I based it on the message queue. It's it works, but it's not that much polished. So the goal has been kind of achieved, because I was able to mine the data set for the game, and currently was able to focus on machine learning more. So there's a ASCII cinema, rather detailed one. It's 35 minutes around, but I'm gonna just skip through it, because there are some funny stuff I faced when I began just understanding how Radare works in November and up to the moment maybe of March. So really interesting things. Okay, so I put on GitHub the snapshot of the game from the Steam, so you can download the vanilla binary. It's not cracked, so just can unpack it and make sure that when the guys update the game, you have the very same binary. You can download it, put to the temp folder, then run make recover, and you will get the binary inside the build folder. Kind of this. So what's next? Let's try to open it up in Radare and patch the game. The binary is 32 bits, it's Linux one. Although the game is cross-platform, I used only one for Linux because of no need for cross-platform support. Okay, so the game has the Steam API shared library. That one that we are going to stub and use as the easy way to inject some random stuff to the binary, because otherwise you would have to make sure that you have enough space to inject some assembly, and it can be done with adding additional segment to the binary, marking it as RVX with some like hex editor. And the other option is like really to dive into the dynamic loader and hack it that way, but it's like lots of time. So the Steam API contains not that much. You can easily fetch the SDK headers from the GitHub just to also read the documentation to understand the like duck typing of these methods, like just what's the idea behind, to make sure that you will be able to stop them as quickly as you can. Another thing, Radare it has its own scripting language. I don't know what's the name of it. I call it r2con2018. So the thing is that when you have like a couple of technologies, you would like to stick with them. And the previous day, the talk of Matt Brooks, he's been doing lots of stuff on top of Radare, and he used R2pipe, and it's really cool because you have lots of power of Python. Like if you need to generate some snippet of R2line code, you can easily do it with string operations and leave all the like say regex related logic or do some simple iteration in Python, not to try to figure out how to do it in R2lang, because like what for to learn another language. So funny thing is that Radare allows you to spot out the socket interface for it, and you can do it with a dot, colon, and the name of the port. But by default, it makes it to 0.0.0.0. So this is actually the not a Trojan, but what did I write? Backdoor to your computer, because you can run shell commands. And I've been using Radare this way for about 2 months. Then I realized, oh shit, I've been using it in public networks. So I, just for fun, I added the flag I needed. It's called TCP is local. Yeah, you should set it to true. I still left it as false. So by default, this is backdoor. Okay, so for patching, I use those like 8-9 lines to, it goes to the position of some Lua method and stubs some commands with the call to Steam API function, which underneath is actually ours C++ module, and it sends there some specific way to make sure that this call is not like the Toribash one, because you use the same method for 2 different things at all. So like type inference won't work in this way, certainly. And we pass there the pointer of lower context we got from Toribash. If you didn't open the file in read-write mode, the patching would fail, as it is here. So we reopen it with OO+, and then I just run my Python code that talks to Radare through the socket. This way, I make sure that I have, say, beautiful IPython console. I can have the completion. I can do like quick prototype in Python, and I'm not dependent on the synchronous way of operating with Radare. So after patching the game, you should compile some libraries, the C++ one that makes the bindings on the Toribash side. I just basically do LD preload to inject the library into the Toribash, and since it has all the required symbols, Toribash does not complain about missing libraries. I think maybe I have like libstim _ API.so library with no symbols at all. Yeah, that one. That's why, because like to make sure that the linker won't complain about missing library files first, then it will be satisfied with the symbols actually. Okay, so these are kind of the project, the folder of a project for the C++ bindings. Like I have the Steam API.h, it matches the SDK1 to make sure you are compatible with the library. The .cpp, it implements the calls, but underneath most of them like either do stubbing yeah, like here, there's a method that allows you to get the pointer to the Steam Friends interface, and the Toribash at the beginning asks for a specific method. I just called it virtual method at the offset 1c. It's kind of the fourth or the fifth one. So I just construct the memory with a single pointer to a virtual kind of table. All this stuff is static just to make sure it won't be deleted upon exiting the function. And the method itself returns the fake username for the Toribash, like Torigood, I think. Okay, so and the environment HPP and CPP, this has extra environment. The data structures, they're the same with Python. In Python, it's C types. In the C++, it's just the structure definitions. What's funny, not funny, but the goodness of the SDK that you can put the callbacks for almost any event inside the game, like each frame being rendered, you can get the callback. You can get even callback for the mouse movements or making any kind of changes. So for the lower part, I just put the hook for the beginning of a game, for the game step, and for ending of game. And since this is Lua, no, it's just kind of any language API in DC. You can just attach any C function to the one inside the Lua, and when I type like page Toribash enter freeze callback, this one from Lua will, no, when you call, no, I think I even didn't declare them inside the Lua. So the function main on the left side, this is the stuff that binds the behavior of a game to callbacks inside C++. So make sure you have enough of control over the game to not to look at it all the time and keep staying inside Python. There was one problem, is that when I compiled the Lua, just the latest one, when I was fetching the pointer and using the symbols from the library, almost all the time it was crashing because the context structure, it wasn't matching the version. So at least with the latest one, I was able to ask for get version from that context. It gave me 5.1. I recompiled exactly that version. I was lucky they didn't make some changes to the config. So it was working, because otherwise you would have to guess the config parameters as well, because in Lua you have like rather fine granular control over the amount of bytes various types will take. So that's why I thought that probably the static linking of Lua was because just enterprise, you do it quickly, not because of doing obfuscation. Okay, so maybe some demo time, I think. What's funny is that the game is single-threaded. That's why if you need to mine some samples from the environment with like static policy, you can occupy all of the 4 or how much you have processed on the cloud, for example, and okay. Okay, so this is the game. This is kind of really funny, but it's more funny to make the bot that will be able to act as these replays, because what's funny is that in 2008, 2013, all of these replays, they're made by people with lots of attention and picking up 22 controls for each time step. Like, just imagine how long they were developing the art of playing in this simulator. Okay, so to use the environment, you need to do a singular call from Lua to initiate the bindings. So it's been loaded. Now you can do Lua main, and you provide the it's just the message queue ID, like for example. One. Okay. Okay. So we click space. Now it kind of works. We get that the interface has been called. So now inside the Python, yeah, here it is, our message queue. Since it's stupid implementation, it's each time I do reset, I need to finish the episode. Okay, now we have the step tensor. It describes there's the raw C-type structure. It has much more structured data, but in machine learning, do just the array of numbers. It has the state of all the 22 controls per each player, as well as 3D positions for each 20 joins per player. You can fetch even more from the game. It was just no need for me for now. So let's close the environment and call the function I used to mine the dataset, for example. Yeah. So you provide the API key. It's resetting the environment, so it's fine. Okay, so the idea that in 2010, the guy who was not that much frustrated with Lua, he decided to do machine learning inside Lua. So the goal, this is actually Python, but the goal was that he took some behavioral policy for both opponents and just was able to to simulate the environment and to fetch some maybe data for statistics. In my case, I just put the uniform distribution over the actions and made the game, made two bots, like the stupid ones you can imagine, to play with each other. I began with a data set with 2.5 million of steps. Then I faced some problems with the skewed, the probabilities were skewed because of random exploration policy. Like that's why I decided to mine even more. So now I have 26 gigabytes of these snapshots of this bullshit. And the current problem is that the machine learning doesn't work. Like, I mean, the bot doesn't learn properly to act. So, but the goal I had, like, to be able to work with Radare, it's been achieved successfully with the help of like 10 lines patch in Radare and lots of stuff before to coming up to that like rather short solution for a problem. So that's it. I think you can find the code at the GitHub, the links to datasets. I have big one published on Kaggle if you want to. Here's the QR code to the Eskinema, the full one, the link. Slides are available at my GitHub. I will publish them to Telegram channel as well. So thanks for attention. It's been nice telling to you about the stuff I've been doing.
Okay. Any question? Okay. Thank you.
Gracias.